Hey guys, so today I'll be talking about how to implement minimization or caching in our top-down DP solution. And to recap what we did last time, we wanted to make sure we do not repeat the same problem over and over. So if I do a problem, I save the result with a unique key to it. Okay, so for example, before memoization, tree would have had the 2, 1, 0. Okay. But instead, I don't have to go through all of these. What I can do, I can just take my answer from here, whatever answer the subtree will give me, and store the result in my cache over here. Okay? Which is going to save me all the time and the memory that would have had to go through if I let it branch out like before memoization or before caching. I'm just going to use the term caching. Okay? And similarly, this 2 over here, I don't have to branch it out or create more subtrees out of it. Why is that? Because I already did it before. I don't have to redo the whole damn process again. So whatever result I get from the subtree, I'm just gonna store it in my cache. Okay? Okay, so you can see that this is going to make my tree so much better. So much smaller, actually. Okay, much smaller tree. Why is that? Because the runtime is going to be different. Smaller tree means smaller runtime. Okay? Okay, so if we check, well, how many nodes, how many function calls I'm gonna have to do here, I need one function call for every unique number, right? So for example, I need to, because I need to populate my cache, so I need one answer for every single number, okay? So for example, here the 4 will have to make 3 function call, the 3 will have to make 2, 1, 0, and this one doesn't have to branch out. Why? Because it's already done here, okay? This one is good because I did it earlier over here. And for example, this one is good. Why? Because I did it, because in that case, do I have another one? Yep. So this one, oh yeah, because I did it over here. Okay, so you see, one was already done. So I don't have to go through that one again, okay? And if you look at 2, I don't have to go through 2 again because I got the result from over here, okay? And I don't have to go through this 2 is good, right? I did it before. 1, I did it before. And 0, I did it before over here. Also, it's a base case. 3, well, I did the 3. The 3, I did it before. Where? I did it over here. Okay. These 2, and who else? Yeah. So if you look at how many nodes I have overall, I think you might get what, 3, 6, 9, maybe 15 or something. So you notice the runtime is so much faster. The number of nodes I'm creating are much less. Why is that? Because I'm getting the answer and I'm storing it over here. Okay. All I have to do is to reread it from my table. Okay, so that's how the tree is going to look like after caching. Okay, that's the tree. And do I have the other tree? So if you want to see why this will be faster than the other tree, I think I had the other tree somewhere. Do I have it somewhere? Or did I remove it? Oh, okay, yeah, over here. So compare this one. This is before caching. And look at that one. This is like much, much simpler. Almost halfway. Almost half as big as the other one. And mind you, this is only for 5. It's just for 5. Imagine if it was 100 or 1,000. The runtime will make huge difference. So that's what caching is going to save you, memory and runtime. Okay. Okay, so let's implement this in our code. And previously, this is before caching. This is our old solution before caching. Let's run some test cases to see how terrible is our runtime. Okay, so I'm gonna, instead of 20, This is exponential runtime from our previous video. Now I made a 40. Okay, see, it's taken forever because it's exponential runtime. Okay? Okay, see, that's not good. So what can we do? What can we do is to add our caching. So what can we do? Add our caching. So I'm gonna create a cache over here, which is fancy way of saying hash map, just cache or dictionary, okay? And what I'm gonna do, every time I collect my final answer for the node or for the function, before I exit my function, I take the final answer and I store it on my cache in some key, because this is the final answer. This is the final answer I'm returning from my function. So before I return it, I will take it, save it, and make sure I save it in a unique key. Okay, what key I can associate with that answer? Well, it's whatever produced that function, okay, which is remaining amount. So for every single unique remaining amount, I have an answer for it. Okay? And then I can return this, or I can just return whatever in my cache already. It's the same value anyways. Okay? Okay, so basically I'm saving the answer that I was about to return to my parent function or parent node. Okay, now let's imagine this new function was recently got spawned or created by its parent function. Okay, do I really want to go through all the work, or shall I see first if I can go through a shortcut? Obviously, I need to check if I have a shortcut. What's a shortcut? Well, I want to check, is that value, or were this value already been calculated or not? Is this value in my cache? Was it calculated before or was it not? If it was, then I don't have to go through all of this. I don't have to go through any of that, okay? That's like, I don't have to go through this. I don't have to go through the for loop. That's a lot of mess. So if it's already there, I can just take it and read it from my cache and boom, return it. I'm good. I don't have to go through the rest of the function, right? Okay. And yeah, actually that's about it. And oh yeah, one more thing, by the way. Okay, let me just run it first and then let's discuss something else. Boom. See here, even was 40. Actually, let's make it 400. How about that? You see, it was struggling with 40 earlier, and I made it 10 times bigger. It's faster now. Okay, that's a difference between linear runtime and exponential runtime. And we talked about this in the first video, but this could be summarized, but you need to convince yourself of that rewrite. I'm going to rewrite this part. And we can rewrite it to be num of coins and equal to the minimum or the previous value we collected with this guy. I'm not going to convince you of this. Try to convince yourself of that part. Okay? This is exactly the same as this. Okay, if this is not comfortable for you, this is equivalent to this part. Either way, doesn't matter, it should work, but this is like more slick, especially for interviews. Okay, so I think that's it for coin change. I think if I have time, I might go through the bottom up. Maybe if I have time. I'm kind of tight on time, but let's see. And if you have questions, just leave comments on the video. All right, peace out.